The confidence interval for the population mean using use of the standard normal. So the problem says the mean diastolic blood pressure for a random sample of 150 people was 94 millimeters of mercury. If the standard deviation of individual blood pressure readings is about to be 12 millimeters of mercury, find a 99% confidence interval for the true mean diastolic blood pressure of all people. Then complete the table below. So we want to know the lower limit and the upper limit. All right, so we can click on the list of formulas. Actually, the first one here is what we're going to use. We want to know the standard deviation or the standard error. So we do the standard deviation divided by the square root of n. All right, so let's screenshot. Write that down before we get it. So we have 150 random people. That is our n, 150 random people. And their mean was found to be 94 millimeters of mercury. Our standard deviation is 12, and we want to find a confidence interval of 99%. Okay. So the other thing that we are going to need to do this is we're going to need to find the z-score. The z-score, it's a z-score that goes along with 99%. Okay, so the z-score that goes along with 99%, go back to the standard normal. That's what that's talking about there. We are trying to capture 99% of this curve. So we want 99% shaded underneath this curve. Okay, so what that leaves, if we do 100% minus 99%, that leaves us with 1% or 0.01. So we have 0.01 on the outside. So we need to figure out how much is on each side. So this is symmetric. So what I actually want to do is divide that by 2, and I get 0.005 on this side and 0.005 on this side. So this counts for 0.005 and this counts for 0.005. So if you're thinking percentages, there's 1% on the outside. So there's 0.5% on each side. So there's 1 total percent on the outside. So we're going to have to find the z-score that goes along with the 0.005 on the outside there. We'll do that in just a second. Let's go ahead and write this out. So our standard error is going to be the standard deviation divided by the square root of 150. Okay? And what we're going to do is take the z-score times that to get our margin of error. So we will come back to this in just a second. So we're going to do the z-score, the z of 0.005, and we get our z-score. So our z-score is 2.575829. So what that means, again, I'm going to have to draw the picture again real quick, but what that means is the z-score that goes along with the 99% is this 2.5758 number. On this side, it's actually going to be the negative of that, okay? And that allows me to keep 99% of this curve shaded on the inside. So now what we're going to do is to find our standard error, we're going to take this number that we have, our z-score, times that standard error, our standard deviation divided by the square root of 150. And that's going to be what we call the margin of error. Use capital E. The margin of error. All right. And when we get our margin of error, then all we have to do is take the mean plus the margin of error to get our upper bound, and the mean minus the margin of error to get our lower bound. Okay. And the capital E is what they use for the margin of error, just to clarify. So I'm going to take this number times 12 divided by the square root of 150, so get that standard error. Now we have, that's our margin of error. So I'm going to store this because we're actually going to use this twice. So what I want to do is, let's do 94 minus our margin of error. So that should be our lower bound since we subtracted 91.476. Where we need to go to, 1 decimal place. So we just got 91.5. All right, and then I'm going to do the mean plus the margin of error. So I'm going to recall 96.5. And that should be our answer. So what this means, again, what you're talking about confidence interval, we're 99% confident that if we went and asked everybody their diastolic blood pressure, it would be somewhere between 91.5 and 96.5.